Okay, guys, welcome to Office Hours. I'm both the instructor and the person leading the office hours for this unit, for Unit 2 of WorldQuant. So welcome, guys. This is a good time to ask your questions regarding the course material and any other thing else you have. I know there might be a lot of logistic questions for the first couple days, so by all means, ask away. Okay, so one of the things that I like to do during office hours is I like to go through the forum. The forum is the best way to ask questions. Okay. So the forum, like I said, the forum is the best way to ask questions. So during office hours, I'm going to go through the forum and answer your questions. But if anyone else has questions, by all means, feel free to bring it up on this chat right here. I'll do my best to answer those questions. So right now I'm looking through the forum, and I usually base the questions, I usually go in the order of which questions have the most votes. So if you like a question, feel free to vote it. I'm going to put priority on that. So someone asks is when will the deadline for doing all the mini projects? And the course deadline someone answered is June 10th, 2019. At least this is the time when the Jupyter Hub closes according to the notifications and the frequently asked questions. That is correct. That is correct. Yes, so to answer your question is everything is due 2 weeks from the end of the course. So after week 8, you have 2 weeks to wrap up everything, and that's when the Jupyter Hub gets shut down. Someone is pointing out that there is a problem with one of the videos. One thing, when you post a question, please, if you post a question and you notice it has gone answered and the person provided the correct answer, please mark it as such. It helps with me to keep track of things. So please mark it as being answered. Let's see, someone is indicating that there is something wrong with the video. So it's one of the videos. Oh, let's see. So 1.3.1, persisting your model is not working. Can you describe by how is it not working? Is it just is it a dead link? Is it not opening up? Can you elaborate on how it's not working? Okay, I'm trying to look for that video. I'm going to see if I can find that video and see what the problem is. But let me know what you mean by it's not working. I'm going to see if I can open it up. And I'm able to play it. I'm able to play the video. So I'm actually going to put the link here. For me, it doesn't show an error. So that might be something on. Okay, link works. Great. Okay. Maybe it was some issue with YouTube for briefly, but thanks for pointing that out so we can make sure that you're able to access those videos. So let me know if you have any other issues. Okay, someone has asked me a question is, could you please discuss hyperparameters and its optimization techniques? Can you elaborate exactly what you want to know about that? In the meantime, I'm going to look through. There's one question here about someone's asking me questions about different parts of the video. And let's see, the machine learning YouTube video has 3 lines of code above. In the explanation, Don talks about the piece of code, the following. It generates a vector from 0 to 1. It generates 100 values from 0 to 1. Okay. So your question is, my first question is, could we not use any other function to produce the same result? Is it similar to the range function where integer values get generated from the code, such as the following? Okay. So the difference here is one generates a NumPy array. The difference is that one generates a NumPy array, and the other generates a list. The thing about NumPy arrays is that if you're going to perform computations, especially on large sizes of these arrays, it's numerically faster if you perform these operations using NumPy arrays. Okay, and let's see. Q2 says, in the linspace, used only for generating decimal fractions, or does it have any other cases? Can it be used like a compound function or list compound function or function of a function? Is the linspace used only for generating decimal fractions? The linspace is not necessarily used for generating decimal fractions, but it's a nice way to create a linear space very conveniently by saying start, stop, and in this case, start, stop, and how many there are. Okay, so in short, it's a great way to easily create evenly spaced numbers from start to stop, giving how many numbers you want. Can a range function in any way be used to generate decimal fractions? I believe so. I think, well, let's think about it. You can say range from 0 to 5, and you can specify how many you want. And I think it should do so. You can always try that out. I guess not. I guess range does not. You give it a step size. Oh, well, range, you have to give it a step size. So I guess if you say a step size of 0.1, can't interpret as an integer. It looks like range complains. Looks like range is only for integer generation. Someone says, can you explain the following snippet where we picked out the exponential between 2 and 3? Could you not use 1 and 4 or something like that? It was just an example there. Could have chosen various things. Okay, looking at Q5, can the Python expression be called a generator of a decimal points? Which expression is doing what here? Let's see. So the choice is simply picking one of those two values. So it's not a generated decimal point. So the linspace is the one that's generating the decimal points. Okay, let me look at Q6. We have a lot of questions. I'm trying my best to go through them all. It looks like it says, this question concerns the snippet. It's about, and keep in mind that you can write snippets very easily by using angled quotes like this. Make sure you use those left-leaning quotes there. So the division by 10 is just for scaling. don't want to produce too large of a random number. We divide by 10. By 10, we'll just visual inspection, kind of played around with a good value to divide by. Looks like 10 was a good one to use. Rand ND is just, and let's see, rand ND is a function to generate values from a standard normal distribution. And shape returns the shape of a NumPy array. In other words, the dimensions. In brackets, though, just pulls out the number of rows there. Okay, and the last question is that the semicolon at the end of a plot function in matplotlib suppresses an output. Okay, so I posted those questions for those that you posted right there. So hopefully that that answers your questions. So there's a question about the Titanic project. Titanic as a machine learning sample project may be a good exercise, but I think it has got discrepancies. What alterations do you think has to be made when it comes to questions of survival of the fittest? This is what happens in the Estonia ferry disaster. In the face of a storm, the ferry will heavily load cargo, especially motor cars, started across the English Channel, and it sank. The weak and the elderly and the old sank while the strong young man survived. And my question is, what is the Titanic model to do with the Estonia disaster? It would be just the opposite. So any prediction based on Titanic would fail utterly. How could you justify that? And I agree that it would be foolish to use the Titanic example to generate 4 actions. Yes, I agree. That's the case. It's not going to. You would not use it in production. You would not use it to drive insight, or in this case, other models. And in that case, the whole point there is that you might want to do a similar workflow, similar analysis, just with different data. So if you have in order to train a model properly, you need to train it on data that's reflective on the application is going to be used for. And in this case, it's not going to be used. It's not coming from the same data, so it's not a good model to use for your analysis. Video links are in the notebooks, are in your Jupyter Hub. So if you go to video downloads, you should see the appropriate videos. But it looks like you're saying that it looks like it's missing one of them. We'll go and try to fix that. But in the meantime, you can view the video. Looks like the link wasn't posted, but so make sure you take a look at that video, and we'll get that fixed. Okay, so it looks like someone was asking me a question about, could you please discuss hyperparameters and its optimization techniques? And it says you started talking about it, you can carry it on from there. So hyperparameters are parameters that govern the learning process. They govern how the model learns. And the reason why that's why they're called hyper, because they exist, quote, one level above standard model parameters. And these hyperparameters need to be tuned. They need to be adjusted such that you can have the best model possible, the most general possible model for your analysis. And there's various techniques for optimizing these sets of hyperparameters. And in general, you would use tools like Grid Search CV. These are tools in scikit-learn that will allow you to programmatically very easily figure out what's a good value for the model's hyperparameters. And we will discuss more of that in the coming weeks. So let me know if there's a specific question you want to ask, but you can view that the model's hyperparameters are parameters that you're able to tweak to adjust the model's performance. Okay, so if there are questions, feel free to ask them at the time. I believe there are no outstanding questions, but there are. Feel free to ask. Now's the time to ask. Someone is asking a question, can you combine several estimators into something like a pipeline? You can combine so long as they're not predictors. So long as they're not any predictors. They can be, let me sketch something up. Show you my screen. So you could combine different estimators using a pipeline. However, these must be transformers. The last one can either be a transformer or a predictor. So yes, you could combine multiple estimators in parallel, but they have to be transformers. They cannot be predictors. So let me know if that answers your questions. I'll move on to the other question posed here. Do we have any Fourier analysis or signal processing or anything of that sort in this unit? Yes, we'll cover that, I believe, in weeks 5, I believe. Fourier analysis. Okay, the floor is open for questions, so let me know if you have any follow-up questions. Go ahead and pose them. I'm going to make sure I answer your questions properly. So someone is asking a question saying we have sinusoidal waveform, a sinusoidal waveform. We cannot use linear regression there. Can we? You can always use linear regression. However, there you might need some sort of feature engineering with linear regression. Linear regression, to make the most of it, is you require some sort of feature engineering. For example, let's say you have, this might be getting a little bit ahead of ourselves, but that's perfectly fine. Let's say you have some sort of time series. You could use linear regression if your model is the following. So it's just a very simple model, just one frequency term. You can expand it to more, but you can, this is basically linear regression. It's just that one feature. This is one feature. Sorry, this is one feature. And this is another feature here. So your model is essentially y equals a times x1 would be plus c, b times x2 plus c. So x1 and x2 are simply sine of 2 pi ft. The other one is cosine of 2 pi ft. So let me know if that answers your question. You just have to be more creative. So your question is, I get the point, but graphically it does not look like it's linear. Well, that's a limitation of linear regression. You can always use any features you generate. However, how well those features will be to predict your whatever you're trying to predict is to be dependent on how linear those features are. The more linear the feature is with what you're trying to predict, the better it's going to be for your task. Someone is asking whether we have SQL or R in this unit. The answer is no, there is no SQL or R in this unit. All right, so someone's asking how many of us are in Unit 2. I don't know top of my head, but there is less than in what is in Unit 1. And there is no SQL or R in this unit. So this question is, could you cast some light onto NLP? Can you elaborate exactly what you're looking to cast interest about NLP? We'll discuss NLP in future lectures, but NLP is all about tasks and algorithms that we can use for that computers can process human or natural language. It's a wide field, lots of different applications. Some of those things is to get idea of sentiment analysis. In other words, given a text, can we identify what's the sentiment? Is it a negative or positive sentiment? Can we do parts of speech tagging? Can we be able to predict what is the rating of a review based upon just a text? That's all the field of natural language processing. So the question is, are there any neural networks in the syllabus? There are no neural networks in the syllabus. Someone is asking, will we be discussing XGBoost in this course? Not explicitly, but we'll be talking about the algorithm that XGBoost is based off of. Extreme gradient boosting is just a variant of gradient boosting trees, just with additional bells and whistles. So when we get to those lectures regarding gradient boosting trees, we can have a more of a discussion about the differences between extreme gradient boosting, how it differentiates between the standard gradient boosting. So there's a question, is there some mini projects on NLP? I was wondering which videos shall we watch to get started with the mini projects? There are two mini projects. There's one called ML, one called NLP. And the ML1 is just a general. You should, I believe, about the end of week 2, you should be able to start attacking it. And the NLP1 is based upon any of the videos that deal with natural language processing. Those are the ones you should watch to get start working on that. Okay, let me know if there's any questions. The floor is open. I believe I've answered all those that have been posed. So someone says, I think shorter YouTube videos would be more helpful for us to follow along. Our videos are difficult to keep track of, especially keeping track of the material and the corresponding timestamp. Yes, the first video is the only one that's an hour long. Everything else is less than 20 minutes, some even as short as 5 minutes. So that problem should be resolved. Yep, so don't worry about that. All right, the floor is open for questions, so ask your questions. So the question is, any function can be a model, can't it? Anything that takes X and predicts Y really can be a model. Anything you can feed it some structured data, something in rows and columns, and give you back a vector of labels is a supervised machine learning model. That is correct. It can be anything really. However, of course, certain ones are more useful than others, and certain ones have been shown to be more adaptive and general purpose. But yes, in general, anything that takes a matrix X and returns a vector Y can be used as a supervised machine learning model. Here, F is the model. Y is the vector of predicted values. Yes, F is a model. Okay. Anyone else have questions? Now's the time to ask them. Of course, there's always office hours on Tuesday, Wednesday, Thursday, so of course more questions will arise. If you have any questions, let me know. Now's the time to ask. So the question is, after the students from this cohort come out, where do they absorbed? Are there any further units after Unit 2? There are no further units after Unit 2. This is just it. This is the final one. I'm not sure what you mean by where do they absorbed, but there are no further units beyond Unit 2. Okay. Yeah, there are no further courses. So someone is asking, what is a laboratory earthquake? Do you have any idea? I'm not familiar with that phrase, laboratory earthquake. So someone is asking, are we encouraged to enter any competitions like Kaggle competitions? It's up to you. I wouldn't say you're neither encouraged or discouraged. However, one of the problems with Kaggle is that they emphasize overemphasis on prediction, and they fail to consider all the constraints that are involved in choosing a proper ML model. There's overemphasis on prediction ability. Very rarely, when you work on a machine learning problem or a problem of data science, do you exist in a vacuum. There are constraints that bound the problem. So if you want to try out Kaggle, by all means, it's a great way to try out your techniques. But it's, I would say neither encouraged or discouraged. So with that said, we're coming to the end of office hours. So if you have any further questions, feel free to post them on the forum, and or come back for office hours tomorrow. So take care, guys. Take care, guys. Have a good rest of your day.